College Algebra, Chapter 1, Section 1, 1.1, page number 58. And this is an introduction to graphing. Lots and lots and lots of this stuff is review, so we're going to just kind of whip through this pretty quickly because it is review, and that should make it not quite so painful. So, what we're going to do here is look at page number 59, and just talks about coordinates in a graph. You know, the first coordinate and the second coordinate. First coordinate is your x value or your abscissa, and your y coordinate is your second one, and it's your ordinate. Example 1 just reminds you of how to graph and label points. So you might want to glance at that. Then you've got solutions of equations, and some examples on linear and quadratic equations. Obviously, your linear equation is going to look like this. And the thing about a linear equation is the exponents on the variables that appear are going to be 1. So that makes life a lot easier. This is the standard form of the equation, which is actually ax plus by equals c. So we're in that form. And what we're going to be doing is being able to look at that equation and graph. And what you've done in the past is you put it in slope-intercept form, which is y equals mx plus b. So what you would have done with that is you would have made it 3y equals negative 2x plus 18. Divide each of these by 3 and end up with y equals negative 2/3 x plus 6. So there you are in slope-intercept form. There's your slope and there's your y-intercept. So you've got a graph like that, and you count up here 6 points, and that's where it crosses the y-axis. And then the slope says we go down 2 and over 3. Down 2 and over 3. And we get a graph that looks like that. It's going from left to right downhill, and that's what that negative sign tells us. And we've got our graph. On the other hand, there is another way to graph these, and a way that I would like you to get used to doing, because we'll be doing it a lot, and that is not only just finding the y-intercept, but also finding the x-intercept. So in a graph, let's do this in black, in a graph, where the line crosses the y-axis is the y-intercept, and where it crosses the x-axis is the x-intercept. Okay, now this is one thing that is very true. When this line crosses the y value, the x value will always be 0. So this point right there will be 0 something. In this case, let's just make it 3, just looking for a number that'll work. Okay, and for an x-intercept, the y value is 0, so we may have come over 3, but we didn't go up or down, so it's 0. So if we can find the x-intercept and the y-intercept, we've got 2 points, we draw a straight line, and we've got our graph. So what do we do with an equation like this? Well, if we want to find the x-intercept, we plug 0 in for y. So 3 times 0 is 0, so that equals 18. And x equals 9. If we want to find the y-intercept, we put 0 in for x, and we get y equals 6. So then I know that it crosses at y equals 9, and it crosses at y equals 6. Now these values that I wrote up here were just, I just drew a line and just came up with that, so those are not accurate, but for this equation anyway, So x is 9, y is 6, draw a straight line, and you're good to go. Let's see, if I jump then all the way to example 4 on page 62. So on this particular one, example 4 on page 62, they're solving it according to the slope-intercept method, so y equals mx plus b. So they just very quickly and easily wrote this like this. And then they divide by -5, divide by -5, divide by -5. And they get y equals 3/5 x plus 2. And there you go. Okay, not a real bad way of doing it. You know, that's the way we're taught how to do it. But let's try doing the same thing using the x-intercept and y-intercept method. So, if I want to find the y-intercept, I'm going to put a 0 in here. Okay, that gives me, whoops, it's an equal sign, -10. So that gives me, divide by -5, divide by -5, and that gives me y equals 2, which if you remember from the last one where you had the slope-intercept form, it was y equals 3/5 x plus 2, and the last number is always the y-intercept. And now we're going to take 3x minus 5 times 0 to find the x-intercept equals -10. So 3x equals -10, so x equals -10 thirds, or 3 1/3. And if you look at the picture of the graph on page 62, you'll notice that when we have our graph here, we had it cross at 2, and then it crossed down here right before we got to 4. So it went like this, and that seems to work just fine and dandy for our x and y intercept. Alright, so in most equations, especially when you have them in y equals mx plus b, whoa, that's sloppy. When you have it in y equals mx plus b, one of the things that is true is that your x value is your independent variable and your y value is your dependent variable, meaning x can be any number we want and y is going to depend on what value we put in there for x. Now when you get a problem like example 5, y equals x squared minus 9x minus 12, at this point, I'm assuming that you don't know how to graph parabolas. So what we're going to do is we're just going to plug numbers in for your x and y value. And when you get your drawing, it's going to be like the picture there. So you're just going to go ahead and put it like a -3 in for x, and it's going to spit out a 24 because, again, x is your independent variable. X can be anything you want, and then y is going to depend on what you put in there for x. So you just put in a few points and you've got your parabola there. Alright, if you continue to look and go across to page 64, you'll notice there's an equation with the distance formula, and they've got a story problem there. And let's see, for the most part, if you look at that drawing, that's pretty much what you need to do in order to come up with the distance formula. I'm not spending a lot of time on that because we just went over it in intermediate algebra last semester. So I'm just going to write it, and this is at the top of page 65. And this is all based on the Pythagorean theorem, a squared plus b squared equals c squared. Okay, so here's like my a squared, here's like my b squared, and d is my hypotenuse, and normally it's squared, but if I took the square root of both sides, the d no longer has the exponent of a 2 because we took the square root of both sides. So that's where that square root came from. So this works really handy, especially when we're working on things like a graph with 2 points. Let's say we've got a point there and a point here, and we want to find out how far it is from there to there. Well, if we find out how high they are from each other and how far left to right they are from each other, we can use our distance formula and find out. So for example, if this was -3, -5, and this was, let's say 5, 7, we could use the distance formula to find out how far it was, or is, from there to there. Because all we have to do is say d, the distance, that hypotenuse, is equal to square root of the difference of our x values squared plus the difference of our y values. And so then we take d equals, and this isn't in the book, I just made that one up. So this is 8 squared plus 12 squared. So the distance equals the square root of 64 plus 144. So d equals the square root of 802. Square root of 208. And then you can go ahead and reduce that. And when we're talking about distances here, so that we understand the length, it's good to know the decimal of 208, what the square root is in decimal form. So that if it's like 14.36, well, 14.36 makes a little bit more sense in your head than the square root of 208 does. So when you're looking at distances like that, you know, you're okay. Page number 76. If you look there, we're doing something with the midpoint formula, and that comes in handy, and it's, for the most part, just x plus the second x divided by 2. That's going to be the x value, and the y value is going to be that. Alright, so what does that mean? That means that if we have a graph, and I have a line from here to here, and I want to know not how far it is to the middle, but if I want to know this particular coordinate, I want to know what the x value is and the y value. I want to know how to get there. So that's what this does. So for instance, if I have, as an example 8, I've got -4, -2 as one point. So let's get rid of my, let's put a line or a dot there at -4, -2. Okay, so let's say that's that point. And the next point is 2, 5. So 2, 5, let's say it's that point, and I want to know halfway through here what point that is right there. I want to know what that address is, for lack of a better term. So all I do is use this formula that I have up here at the top. So I'm going to take my first point, or my first x, -4. I'm going to add my second x, and I'm going to put that over 2. I'm going to take my first y, and I'm going to add my second y, and I'm going to put that over 2. So that point is -2 over 2, 3 over 2, or -1, 3 over 2. That point right there is what I should be getting right there. About -1 left and 1.5 up. Okay, so that's the midpoint formula. And that works real handy when you've got the diameter of a circle, and you know where both of the you know where points on the circle are, and you know that between those points on the circle there is a see if I can get rid of this, just like the drawing that they have there on page 66. They've got this graph, and then they have the circle. and then they have a point right here, and a point here, and a point here. So we've got our diameter. Well, we may know this point, and we may know this point, and we want to know what our center point is right there. Well, if we know this point and this point, we just do the midpoint formula, and we're able to find the center point of that. So that makes it good, which brings us into the topic of circles, which shows up on the top of page 67. It's a set of all points in a plane that are a fixed distance r from the center hk. So we've got a center, and let's just go ahead and make a graph here. And the distance left that we made to get to there is our h, and our height, do this in red, that goes up, that's going to be our k value. Okay, so that's our center point, is hk. So let's just go ahead and make an hk there. And a circle is the set of all points that are the same distance from hk. And there's an infinite number of points from there, and we call that distance from the center point to a point on the circle, we call it r for radius. Okay, and we use our distance formula that we used before, because our r ends up being the hypotenuse of a triangle. So we have x minus h, which is our x coordinate in the of the center of the circle, y minus k, and that quantity squared. Okay, so what we have is, let me see if I can get rid of a bunch of this mess here so you can see what we have here. Let me erase that, and let's see if we can get a circle up here. So that point is hk. Okay, so if we're interested in the radius, and let's say that we know this point is x, y. Okay, so what we know is our x coordinate and our y coordinate, and we also know our center point. And if we have this into a triangle, notice that the r becomes the hypotenuse. And we know that the distance from here to here is going to be the y value minus the k value, the difference between the k and the y right here. Okay, so that's where this came from. This distance from here to here, this point is x, this point is h. Well, h is from here all the way here, and x is from here to here. So in order to find the distance between here and here, we have to take the difference between the two. Now again, it looks like maybe this should be h minus x and k minus y. It doesn't matter. It doesn't matter which of these values go in here. You could switch them around and have h minus x and k minus y. It doesn't matter. You're going to have the same answer, because whether you get a positive or a negative, when you square this, it's going to be positive. So it's all going to come out fine. So for example, if my y was a 3 and my k was a 4, I've got 3 minus 4 is negative 1. I square it, I get 1. If I did it as 4 minus 3, that equals 1, and you square it and it's 1. So it doesn't matter. It works whichever order you put those in, so don't get confused with that. Which brings us to the equation of a circle in the purple in the middle of page 67. X minus h, the quantity squared, plus y minus k, the quantity squared, basically equals r squared. The only difference between the blue equation here and this black one here is we took the square root of both sides up here. So the 2 disappeared and a square root sign appeared above the right hand side. So anyway, when you're graphing a circle and you have to get it in this form, you know that your radius is going to be the square root of whatever that is. So for example, if I had an equation like example number 11, I've got x plus 5, and I square it, and I have y minus 2 squared, and I say that's equal to 16. Well, that 16 is actually r squared, so the r then is the square root of 16, which would be 4. Okay? So, if they want you to graph this, you're going to rewrite this here in this form right there. So, shouldn't be too terribly hard, because x plus 5, if we're going to write it in this form, has to be written as x minus negative 5. Then we've got our x plus 5 that we have here, but we're writing it with a minus sign there, like that. So in order to do that and not change the value, we have to make that a negative 5. And the same thing we're going to do with the y value, but the y value is already negative, so it's just going to stay negative. So that's squared, and that's squared, and that equals 4 squared. My radius is 4. And so that tells me that my center, because HK, that tells me my center is negative 5 from here, and 2 from here. Okay, so notice I took the 5 and I took the 2. Okay, so this right here is all I'm looking at, negative 5. X minus negative 5 is my h. Y minus positive 2, and that goes there. Okay, so don't let that confuse you. That's one of the reasons why you write it as this as x minus negative 5. Some people will look up here and say, okay, what's going to make this 0? A negative 5. What's going to make this 0? A positive 2. And then you don't have to fight with the signs here, but I wanted to show you this because that's actually where it comes from. So, if you look at example 10, it says find an equation of the circle having radius 5 and center 3, 7. Okay, so if we take our equation of a circle, and that being x minus h squared plus y minus k, quantity squared, equals r squared, and it tells us that the radius is 5. So we're going to replace the radius with 5. And it also says that the center is 3. So remember, these are the center coordinates. So x minus 3 plus, and it says, let's see, what's the other one? Negative 7. Y minus negative 7. Okay, so x minus 3 squared plus y plus 7 squared equals 5 squared, or 25. See, I made that into a positive 7. And there's my equation of that circle. Okay, so that is it for exercise 1.1.